Hello, everyone. My name is Tianyi Zhang, and I'm a assistant professor in the Department of Computer Science at Purdue University. Today, I want to tell you a little bit about the Secure Chain Knowledge Graph from the NSF Proto-OKN program. The motivation behind this project is the increasing number of software supply chain attacks in recent years. Because of the interconnected nature of modern software, the vulnerabilities or malicious code can spread very quickly in the software ecosystem. So there is a pressing need to address this cybersecurity threat. Existing tools for software component analysis and vulnerable dependency detection have several limitations. First, most of these tools only check direct dependencies. They have limited support for transitive dependencies. In other words, if your software depends on a package that itself depends on another vulnerable package, then today's tools usually miss those risks. And second, those tools only rely on a narrow set of cyber intelligence sources, often excluding timely information from informal security reports and social media. Third, they provide limited support for C and C++, which is the most prominent programming language that accounts for almost half of the known vulnerabilities today. And finally, they do not provide a global view of the vulnerability propagation. So security experts have a hard time tracing how a single upstream vulnerability can cascade across downstream packages and applications. So together, this limitation highlights the urgent need for a more comprehensive, dynamic, and cross-ecosystem solution. And our solution is to build a large-scale knowledge graph that captures the entire network of existing software components available on the market, including their direct and indirect dependencies, and also the vulnerabilities associated with these components. So when a new cyber incident occurs, we can quickly perform a whole graph analysis and model all the vulnerability propagation passes, so we can make a comprehensive risk assessment and make an informed plan to contain and reduce the damage caused by this incident. So why do we choose to build a knowledge graph, you may ask? Software ecosystems basically form networks of packages, libraries, frameworks, and applications. And a knowledge graph is the natural way to represent this structure. And also, it integrates data from different silos into a unified data model, enabling reasoning over complex relations, providing a visual way to explore dependencies and vulnerabilities. You can name quite a few good properties about knowledge graphs. SecureChain is built on multiple authoritative and real-time data sources. This includes the CVE list, the online project repositories, software package managers, cybersecurity advisories from federal agencies, and also cybersecurity news articles. Currently, SecureChain tracks over 12 million software components, 461 million dependencies, and 259,000 vulnerabilities across 7 popular programming languages. So how do we build this knowledge graph? First, we develop rule-based data extraction scripts to extract knowledge triples about vulnerability and software dependencies from structured data sources like the CVE list and the package managers. And for online code repositories on GitHub and Debian, we develop program analysis tools to perform software component analysis and extract software dependencies. And finally, to capture insights from unstructured data, like news articles, we developed a LLM-based pipeline that recognizes software and vulnerabilities mentioned in an article and extracts them as knowledge triples. This allows SecureChain to stay updated with both official intelligence and emerging informal intelligence from the public. SecureChain supports a wide range of use cases like cyber risk analysis, automated vulnerability monitoring, SPOM construction and validation, and patch prioritization. Its value also extends across multiple user groups like security researchers who want to develop new cybersecurity tools, industry practitioners like software vendors, cloud providers, and a small business who want to meet the new SPAM requirements and audit their own software. And also government and defense agencies who want to perform national cyber risk assessment and make quick responses to cyber incidents. Here, I want to show you one example about a vulnerability in a popular network communication library called OpenSSL. You can see that SecureChain can trace not just the direct impact of this vulnerability, but also how it propagates into hundreds of downstream applications like Android NDK, MySQL, Docker, and Google Cloud. This provides a clear picture of the real-world impact and helps prioritize strategies to contain and fix this vulnerability. Now let's look at how SecureChain fits into the big picture of Proto-OKN. SecureChain is one of the 13 knowledge graphs in the Proto-OKN ecosystem. It's stored and federated in the Flink infrastructure. You can access it through the Proto-OKN API toolkit or through the online user interface developed by Spider. And we are also working with Spider to integrate the Sparkle query visualization to help non-experts understand and debug the auto-generated Sparkle queries. SecureChain can also complement other Proto-OKN efforts in domains such as climate change and healthcare, which increasingly depend on complex software for computation. For example, we have used the SecureChain to check the climate models in Climate PUB4KJ knowledge graph. And our analysis revealed that there are 24 vulnerable Python dependencies with 145 known vulnerabilities in the climate models. This demonstrates the importance of a secure the software supply chain behind critical scientific software. In addition, we are working with the StuCon team to develop a joint knowledge graph for semiconductor supply chain security. This work extends SecureChain's capability and methods to cover vulnerabilities in semiconductor products such as CPUs, GPUs, and memory components. Currently, our knowledge graph tracks over 5,000 vulnerabilities associated with the semiconductor products from 239 companies like Intel, NVIDIA, and Qualcomm. And if you are interested in learning more about SecureChain, you can find the details in our project website. We also have open source SecureChain on GitHub. You can find all the data, ontology, and knowledge extraction scripts there. And if you are interested in testing SecureChain, you can use the online Sparkle query interface from Flink. It's completely online, and you don't have to install anything. And finally, our long-term vision is to grow SecureChain into a sustainable and also the largest open source ecosystem for software supply chains. This ecosystem will include not only the knowledge graph itself, but also a suite of security tools built on top of the knowledge graph. And we are currently collaborating with Red Hat, BAE Systems, and Lockheed Martin to co-develop these tools. At the same time, we hope the broader open source community can enrich SecureChain's data sources by integrating timely cybersecurity intelligence from well-known blogs and social media accounts. Through these efforts, SecureChain will evolve from a research prototype into a community-driven platform that continuously monitor critical cyber infrastructures 24/7 and expands its impact across national security, industry, and academia. Thank you.